In this skill, we're again going to be using dimensional analysis to convert between the charge passed through an electrochemical cell and the amount of a substance produced. But this time, we're also going to be calculating the volume of gas produced or used up. So same as before, we're going to be converting between charge into moles of electrons, from there into moles of our substance, I'm going to call X. But this time, once we've got the moles of our substance, we're then going to be converting into liters of our substance. We're also going to be using the Q equals IT equation to convert between charge and current and time. In this particular question, we're told a scientist wants to determine what volume of chlorine gas, Cl2, at STP could be made by passing a steady current of 1.06 amps through an electrochemical cell for 144 seconds. So we can see here we've been given the current, that's going to be I in our Q equals IT equation. We've been given the time, 144 seconds, that's the T in our Q equals IT equation. So we'll be using that to find the charge. We're then going to be converting from charge into moles of electrons. Then we're going to convert from moles of electrons into moles of chlorine produced. And finally, we'll convert from moles of chlorine produced to liters of chlorine produced. Let's start by calculating the charge using Q equals IT. So there's our equation. We're trying to find the charge Q, so this is already arranged correctly. So all we need to do is put on our numbers. I is the current, which is 1.06 amps, multiplied by T, which is the time, which is 144 seconds. So if you put that into our calculator, we're going to get a charge of 153 coulombs. So we can go ahead and fill that in up here. So that's our charge, which is going to be our starting value in our dimensional analysis table. Then we're going to be going through all our steps to convert into liters of chlorine. To convert between charge and moles of electrons, we're going to need to use the Faraday constant. Here's the Faraday constant. That tells us that 1 mole of electrons is equal to 96,485 coulombs of charge. For the next step, we'll be converting between moles of electrons and moles of chlorine. To figure out the conversion factor for that step, we're going to need to use the balanced half equation for the half reaction involving chlorine. In our equation here, we start with 2Cl-, we end with Cl2. So we start with 2Cl- aqueous, we end up with Cl2 gas. Right now, our charge on the left is 2-, and our charge on the right is 0. So if we add 2 electrons on the right, now our charge on the left is 2-, and our charge on the right is 2-. So that's our balanced half equation for this reaction. So we can see here 2 moles of electrons are transferred in 1 mole of this half reaction. And we can see that to make 1 mole of chlorine gas, we produce 2 moles of electrons. So that's our conversion factor for the second step. Then we're going to convert from moles of chlorine to liters of chlorine. We're told in the question we're at STP, which is standard temperature and pressure. And here on the gases page of our reference sheet, we can see at STP, standard temperature and pressure, the temperature is 273 Kelvin and 1 atmosphere. Under those conditions, 1 mole of a gas takes up 22.4 litres of volume. So those are our 3 conversion factors we're going to need for our 3 steps. So we can go ahead and use those in our dimensional analysis table now. So we're starting with 153 coulombs of charge. We're converting from charge to moles of electrons. So coulombs is going to go on the bottom, so it will cancel out. Moles of electrons is going to go on the top, so we can end up with that. We need the top and the bottom of our fraction to be equal. So 1 mole of electrons is equal to 96,485 coulombs of charge. Next, we're converting from moles of electrons to moles of chlorine. Moles of electrons is going to go on the bottom, so it will cancel out. Moles of chlorine is going to go on the top, since that's what we're trying to get to in this step. The top and the bottom of the fraction should be equal. So 1 mole of chlorine is equal to 2 moles of electrons. Lastly, we're converting from moles of chlorine to litres of chlorine. So moles of chlorine is going to go on the bottom, litres of chlorine is going to go on the top, and then we need the top and the bottom of the fraction to equal each other. So we know 1 mole of chlorine is equal to 22.4 litres of chlorine. Now we're ready to go ahead and multiply everything on the top, multiply everything on the bottom, and divide top by bottom. The coulombs are going to cancel, the moles of electrons are going to cancel, and the moles of chlorine are going to cancel, leaving us with litres of chlorine, which is our goal unit. So we've got 153 multiplied by 1, multiplied by 1, multiplied by 22.4 litres of chlorine, divided by 96,485 times 2 times 1. So if we put that all into our calculator, we're going to get out a value of 0.0177 litres of chlorine. Let's go ahead and fill that in. Awesome. So in this skill, we'll be converting between charge and the volume of a gas. So either you'll start with the charge, you'll find the moles of electrons, the moles of the gas, and then the volume of the gas, or you'll start with the volume of the gas, you'll convert to moles of the gas, moles of electrons, and then charge. To convert between charge and moles of electrons, we're using Faraday's constant. To convert between moles of electrons and moles of our gas, we're going to be using the balanced half equation for that reaction. To convert between moles of our gas and litres of gas, we're going to be using the molar gas conversion for standard temperature and pressure, STP. We're also using Q equals IT to convert between charge, current, and time. As you can see, this skill is exactly the same as the previous skill with grams, but instead of using the moles to grams conversion from the periodic table at the end, we're using the moles to litres conversion at standard temperature and pressure.